To find the derivative of these two trig functions at this point, it's best to use the quotient rule. We're going to go ahead and do that. If you haven't done that yet, push pause on the video and try these two problems. If you have, then follow along and see that you did the same things that I did. I'm going to start with cotangent of x. Cotangent of x is also written as cosine of x divided by sine of x. When I take the derivative of that using the quotient rule, derivative of the numerator, derivative of cosine is negative sine, so negative sine of x, times the normal sine of x, minus normal numerator, multiplied times the derivative of the denominator. The derivative of sine is cosine. And then that is all going to be divided by sine of x quantity squared. If I clean this up, that means the derivative of cotangent is going to be negative sine squared of x minus cosine squared of x, all divided by sine squared of x. Once again, I can use the identity that says sine squared plus cosine squared equals 1 to say that negative sine squared minus cosine squared should be negative 1. So this derivative is the fraction negative 1 over sine squared of x, which is simply negative cosecant squared of x. So notice that when we did tangent, we got secant squared. When we did cotangent, we got negative cosecant squared. So if my function is cotangent of x, then the derivative of that function is negative cosecant squared of x. And that's the derivative of this trig function. The derivative of secant we can find also using the quotient rule. Now let's do a rewrite of secant. A rewrite of secant would just be 1 over cosine of x. So if we want to find the derivative using the quotient rule, we can set up a fraction. That fraction is going to have a numerator which has derivative of the numerator, so derivative of 1, which is 0, times my normal denominator, cosine of x, minus normal numerator, so minus 1, times the derivative of the denominator. The derivative of cosine is negative sine, all divided by cosine squared of x. We're going to clean this up just a little bit. I say clean it up, we're going to rewrite it. to what most people know as the actual derivative. So you'll notice that the numerator of this fraction will have 0 minus 1 times negative sine x. The negative 1 times negative sine gives me a positive sine x. And then the numerator is sine x. The denominator is going to be cosine x times another cosine x. And what I'm going to do is I'm going to rewrite this into two separate functions or two separate expressions. I'm going to write this as sine over cosine times 1 over cosine. And that tells me that if my function is secant, then the derivative of that function is equal to tangent times secant. Or most people will write the secant first. They'll write secant of x times tangent of x. Let me write it that way so that we see that. So we're taking sine divided by cosine squared, which is secant times tangent. So if my function is secant, then the derivative is secant times tangent. There we go. Those are the derivatives of cotangent and secant. Now we found the derivative of tangent already. We were given the derivative of sine and cosine. So what we have basically is the derivative of all of the 6 basic trig functions. I had not done cosecant yet, but cosecant has a derivative which is negative cosecant times cotangent. So it's very similar to secant. So there's my derivatives of my 6 basic trig functions. If I take the derivative of sine, I get cosine. If I take the derivative of cosine, I get negative sine. If I take the derivative of tangent, I get secant squared. If I take the derivative of secant, I get secant times tangent. If I take the derivative of cotangent, I get negative cosecant squared. And if I take the derivative of cosecant, I get negative cosecant times cotangent. Those are the derivatives of the 6 basic trig functions. Now you'll notice that the way tangent and secant work in tandem is very close to the way cotangent and cosecant work, except with cotangent and cosecant, I throw in a negative in each of the derivatives. Whereas with tangent and secant, I always have a positive 1 as a coefficient or an implied 1 as a coefficient. Whereas cotangent to cosecant, I imply a negative 1 here as my coefficient in both. And the reason why with cotangent derivative you get negative cosecant squared is because of the negative on the cosine derivative. In other words, since the derivative of cosine is negative sine and the derivative of sine is positive cosine, when you take those functions and take derivatives of tangent, you end up with positive secant squared. When you take a derivative of secant, you get positive secant times tangent. But when you take a derivative of cotangent, you end up with negative cosecant squared. And when you take a derivative of cosecant, you get negative cosecant cotangent. And that's because of the roles of sine and cosine in these two functions. But secant tangent are paired, cotangent, cosecants are paired, and then sines and cosines are sort of paired in these ways.